There's a lie you've been told since childhood, not a small lie, not a simplification, a fundamental misunderstanding about something you use every single day. Electricity. You flip a switch, light appears, you plug in your phone, it charges, you press a button, a machine comes to life, and in your mind you see it. Little particles racing through wires, flowing like water through pipes, rushing from the power plant to your home at incredible speed. That image is wrong, almost completely wrong. And once you understand what's actually happening, what electricity really is and how it actually moves, you'll never look at a light bulb the same way again. Carl Sagan dedicated his life to showing us that the universe operates in ways our intuitions cannot grasp, that the reality beneath appearances is always stranger, always more beautiful, always more profound than we expect. Electricity is a perfect example. So let me show you what's really happening when you flip that switch. Let's start with what you think you know. Electrons, tiny particles, negative charge. You imagine them shooting through copper wires like bullets through a barrel, racing at incredible speeds, carrying energy from point A to point B. This is the mental model almost everyone has, and it's almost entirely incorrect. Here's the first shock. Electrons in a wire move incredibly slowly. We're talking about a drift velocity of roughly 0.1 millimeters per second in a typical household wire. At that speed, an electron would take over an hour just to travel 1 foot. The power plant might be miles away. If electrons actually had to travel from there to your light bulb to deliver energy, you'd flip a switch and wait days for the light to turn on. But that doesn't happen. The light turns on instantly. So if the electrons aren't racing through the wire, what is? Here's an analogy that gets us closer. Imagine a long tube completely filled with marbles, packed tight, no gaps. Now push one marble into one end. What happens? A marble pops out the other end immediately. The marble you pushed didn't travel through the tube. It barely moved at all. But the push traveled. The pressure wave moved through all those marbles almost instantly. This is closer to what happens in a wire. The electrons don't race from one end to the other. They're already there. Billions upon billions of free electrons packed into every centimeter of copper. When you flip a switch, you don't send electrons on a journey. You send a signal, a push, an electromagnetic wave that propagates through the wire at nearly the speed of light. The electrons themselves, they just wiggle back and forth in place. They're not the messengers, they're the medium. But here's where it gets truly strange, because even this model isn't quite right. The truth is far more bizarre. The energy doesn't travel through the wire at all. It travels around the wire, in the empty space surrounding it. I know this sounds impossible, but in 1884, a British physicist named John Henry Poynting worked out the mathematics of how electromagnetic energy actually moves. What he discovered changed everything. Poynting showed that when current flows in a wire, it creates two fields, an electric field and a magnetic field. These fields extend into the space around the wire, the air, the vacuum, whatever surrounds it. And the energy, the actual power that lights your bulb and charges your phone, it flows through those fields, not through the copper, through the empty space around the copper. The wire is just a guide, a track, a way of shaping where the electromagnetic field goes. But the energy itself travels through what looks like nothing. This is described by something called the Poynting vector, a mathematical formula that shows exactly how electromagnetic energy flows through space. And it's been confirmed by experiments countless times over the past 140 years. Now think about what this implies. Every wire in your house is surrounded by an invisible flow of energy, not inside the copper, around it. The walls of your home are filled with electromagnetic fields carrying power to your appliances. Right now, energy is flowing through the air around you, through the space between atoms, through emptiness. You can't see it, you can't feel it, but it's there, everywhere. Let's walk through what really happens when you flip a light switch. The switch closes a circuit. This allows charges to begin moving, slowly remember, in the wire. But as soon as they start moving, they create electromagnetic fields around the wire. Those fields propagate outward at nearly the speed of light, about 300,000 kilometers per second. And those fields carry energy. When the fields reach the light bulb, they interact with the material in the filament. The electromagnetic energy gets absorbed. Electrons in the filament start vibrating more intensely. That vibration is heat. And when something gets hot enough, it glows. Light. But notice what happened. The energy didn't come through the wire. It came through the space around the wire. The wire just shaped the fields, directed them, guided them to the right place. And this happens at nearly the speed of light, which is why the bulb turns on the instant you flip the switch. Here's another way to think about it. Imagine the wire as a railroad track. In the old model, you pictured a train made of electrons racing along the track, carrying cargo from one station to another. But that's not what happens. Instead, the track creates a kind of invisible highway in the air above it, and energy flows along that invisible highway, guided by where the track goes, but not actually touching the track. The copper guides the fields, but the energy flows through space. Carl Sagan understood something profound about science education. He knew that the models we learn in school can become prisons for our understanding. In his book, The Demon-Haunted World, published in 1995, Sagan wrote about the importance of scientific literacy. He said, "We live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology. Electricity is a perfect example. We use it every moment. We'd be helpless without it. But most of us have a completely wrong picture of what it is and how it works. And that wrong picture limits how we think about the world. Let me show you how strange electricity really is. Think about a simple circuit. A battery connected to a light bulb with two wires. Here's a question that reveals something deep. How does the energy know how much resistance is in the circuit before it gets there? The moment you connect the circuit, the battery starts pushing. But how does the battery know how hard to push? How does it know whether it's connected to a 10-watt bulb or a 100-watt bulb? If electrons had to travel to the bulb first and then report back, there would be a delay. But there isn't. The answer is the electromagnetic fields. When you connect the circuit, fields propagate outward from everywhere simultaneously. These fields interact with every part of the circuit, and the information about total resistance is carried back by the fields themselves. It's the fields that organize everything. It's the fields that carry the information. It's the fields that make the circuit work. But it goes deeper, because this connects to one of the most profound discoveries in the history of science. In the 1860s, a Scottish physicist named James Clerk Maxwell unified electricity and magnetism into a single theory. He showed that electric fields and magnetic fields are two aspects of a single thing, the electromagnetic field. And Maxwell discovered something remarkable. When an electric field changes, it creates a magnetic field. When a magnetic field changes, it creates an electric field. They generate each other endlessly in a cosmic dance. And when this dance propagates through space, when the fields keep regenerating each other as they travel outward, you know what that's called? Light. Light is an electromagnetic wave. The same phenomenon that carries energy through the space around your electrical wires is the same phenomenon that lets you see the light from the sun, the glow of a candle, the screen you're looking at right now. All of it is electromagnetic fields propagating through space. When you flip a light switch, you're using electromagnetic fields to create more electromagnetic fields, fields shaping fields, energy flowing through emptiness. This is where it becomes unforgettable. Everything you see, every color, every shape, every face, is electromagnetic fields interacting with your eyes. And everything electrical in your home is also electromagnetic fields. It's all the same thing. Light and electricity are not different phenomena. They're the same phenomenon, operating at different frequencies. Visible light is electromagnetic waves at frequencies your eyes can detect. The power in your walls is electromagnetic waves at much lower frequencies, 60 cycles per second in most countries. But it's all electromagnetic. It's all fields. It's all connected. Sagan loved moments like this. Moments when you realize that things you thought were separate are actually unified. In his series Cosmos, first broadcast in 1980, he talked about how we are connected to the universe in ways we don't expect. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars, he said. We are made of star stuff. And electricity? The fields that power our civilization? They're made of the same stuff as starlight. The electromagnetic force is one of the 4 fundamental forces of nature. It holds atoms together. It makes chemistry possible. Every electrical device you've ever used operates on the same principles as the light from distant galaxies, the same equations, the same fields, the same cosmic phenomenon. When you turn on a lamp, you're participating in something that connects you to the entire universe. Now here's a question that might keep you up tonight. If the energy travels through fields in the space around the wire, and if fields can exist in a vacuum, in completely empty space, what is the field made of? What is waving? When you have a water wave, water is moving. When you have a sound wave, air is moving. But when you have an electromagnetic wave, when you have light itself, what is moving? This question tormented physicists for centuries. They invented something called the luminiferous ether, a hypothetical substance that filled all of space and carried light waves, but experiments couldn't find it. In 1887, 2 American scientists named Albert Michelson and Edward Morley performed a famous experiment trying to detect the ether. They measured the speed of light in different directions, expecting to find differences caused by Earth's motion through the ether. They found nothing. The speed of light was the same in every direction. The ether didn't exist. And this led to a profound realization. Electromagnetic fields don't need a medium. They propagate through empty space. The fields themselves are fundamental. They're not made of something else. They're one of the basic building blocks of reality. The electromagnetic field is not a thing moving through space. It's a property of space itself. This was one of the great revelations of modern physics. Space is not empty. It's not just a void where things happen. Space itself has properties. It can carry fields. It can transmit energy and information. When you flip a light switch, you're not just moving electrons, you're activating properties of space itself. You're making space do something. Let me share one more idea, something that might change how you think about yourself. Your brain runs on electricity. Neurons fire, signals propagate, thoughts happen. But based on what we've learned, those signals aren't really electrons rushing through your neurons. They're electromagnetic fields propagating through the space in and around your nerve cells. Your thoughts are fields. Your memories are fields. You are, in a very real sense, an electromagnetic phenomenon. You are fields thinking about fields. In Cosmos, Sagan said, "We are a way for the cosmos to know itself." He meant that we, conscious beings, are the universe becoming aware of its own existence, made of atoms forged in stars, powered by electromagnetic fields, thinking about the nature of reality. And now you know something about yourself that most people never learn. The energy that powers your body, your devices, your civilization, it doesn't flow through wires. It flows through space, through fields, through the same invisible medium that carries starlight across the universe. So here's what I want you to remember. Next time you flip a light switch, pause. Think about what's really happening. You're not pushing electrons through a wire. You're creating electromagnetic fields that expand outward at nearly the speed of light. Those fields carry energy through the empty space around the wires, through walls, through air, through the invisible gaps between atoms, and when they reach the bulb, the fields give up their energy and light appears. It's a dance of invisible forces, a flow of power through emptiness, a phenomenon that connects your bedside lamp to the light of distant stars. Carl Sagan spent his life trying to awaken people to the wonder that surrounds us. Not made-up wonder, but real wonder, the strange, beautiful truth of how the universe actually works. In Cosmos, he said, "The universe is under no obligation to make sense to you." And it doesn't. It does things its own way, by its own rules. Electricity doesn't work the way you thought. And that's not a problem. That's the gift. Every time you discover that reality is stranger than you imagined, you see the world with fresh eyes. You feel the wonder again. Sagan also said, "For small creatures such as we, the vastness is bearable only through love." I think he was talking about the vastness of our ignorance too. There's so much we don't understand, so much that remains mysterious. And the only way to bear that is to love the questions themselves, to find joy in not knowing, to be amazed that there's still so much left to discover. So tonight, when you reach for a light switch, pause. Think about the fields you're about to create. Think about Maxwell, who unified electricity and magnetism in the 1860s. Think about Poynting, who showed where the energy actually flows in 1884. Think about Michelson and Morley, who proved that light needs no medium in 1887. Think about all the people who looked at something ordinary and asked, "What is this really?" And then flip the switch. Watch the light appear. And know that you've just participated in something ancient and strange and beautiful. The fields that light your home are cousins to starlight. The energy flowing through your walls is governed by the same equations that describe light crossing the universe. You're not separate from the cosmos. You're wired into it, literally. And once you see that, you can't unsee it. The universe is not what it appears to be. It never was. And the electricity humming through your walls is proof, silent, invisible, everywhere, carrying energy through emptiness, connecting you to everything right now. Quotes used, "We live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology." The Demon-Haunted World, 1995. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. Cosmos, 1980. We are a way for the cosmos to know itself. Cosmos, 1980. The universe is under no obligation to make sense to you. For small creatures such as we, the vastness is bearable only through love. Cosmos, 1980. Verified scientific references. John Henry Poynting, Poynting Vector Theorem, 1884. James Clerk, Maxwell, Unification of Electromagnetism, 1860s. Albert Michelson and Edward Morley, Ether Detection Experiment, 1887. Electron Drift Velocity, 0. Wood-Bemidton S in typical household wiring. Electromagnetic field propagation speed, speed of light, the four fundamental forces of nature, luminiferous ether hypothesis, 19th century, works referenced, The Demon-Haunted World, book 1995, Cosmos, A Personal Voyage, TV series 1980,